majority of the boats, the commercial pleasure boats, pleasure yachts, the hull is a V hull, like the hull that we have on the screen right now. Those are V hulls, but the inconvenience with the V hulls is that they require a lot of energy, a lot of power to reach the cruise speed. Of course, when the boat is at cruise speed, the consumption of fuel and energy is less. Yeah, of course. But what about in between the stationary position and the cruise speed? You need to spend a lot of energy, a lot of fuel in order to reach the top cruise speed. Remember that the gasoline is lighter in comparison with diesel. How much? Gasoline is 6.1 pounds per gallon, the weight, and diesel is 7.1 pounds per gallon. Yeah, diesel is a little heavier. And don't forget that in general terms, the diesel is in between 15 and 30% more efficient than gasoline. Yes, my friends. The diesel engines are highly efficient. Don't forget that this is very important. This is the point. If you check this curve is the torque, and this one is the horsepower. And we are going to analyze the majority of our studies, the majority of our analysis are located. You remember in the previous class the calculation of the turbo, the calculation of the motor mounts, all the calculations are related with the point where the engine is at maximum efficient. And normally that point is the point where the engine produces the maximum torque. 86% of the energy produced for any type of engine is dissipated in heat, in friction, in vibration, in Only between 13-14% in a good scenario is used to produce torque and thrust. A little, no? My friends, 85% of the money that you put on the fuel tank is bye-bye, and only 14% is used to produce the movement of the boat. Yes, my friend, the electrical cars, the electrical boats, the electrical planes are the future. But we need work, we need investigate, we need study, and we need discover better materials to storage energy. The inconvenience are the batteries. Of course, every day the people discover better batteries. But today we don't have the ideal battery. This is the inconvenience. Yes, my friend, you need to study more. And probably in 30 years we have eliminated the majority of the internal combustion engines, and they are replaced for other type of motors, other type of engines that produce your own energy. I don't know if the electrical is the solution in the future, but in the next coming future, probably the electrical is the future. Okay, suppose that I have a diesel engine, 150 horsepower, and I have a gas engine, and the same capacity in horsepower, 150 horsepower each engine. And once again, for diesel, I am going to multiply the horsepower 0.055. I am going to multiply the horsepower times 0.055, and for gasoline, I am going to multiply for times 0.1. Okay, 150 times 0.055 is equal 8.25 gallons per hour. And 150 times 0.1 is 15 gallons per hour. the consumption of the gas engine in similar conditions is double practically than the consumption of the diesel. The basic components of a typical outboard engines, we have on top the power unit. The power unit is could be 2 strokes or 4 strokes. The middle section is the section where the gases are controlled, especially the exhaust gases. And the lower unit in the bottom is basically the transmission. Is the gear case, the gearbox, or transmission. We have 3 elements: the power head, the middle section, and the lower unit. Those 3 sections are the components of the outboard, and we are going to study each of those components in this class and the next coming class, transmissions. For 2 strokes, and remember, in 4 strokes you have the valves located on the head, the intake and the exhaust valves located on the head, and the camshaft is connected with the crankshaft by means of the timing chain. Right? This is in 4 strokes. In 2 strokes, what happened in 2 strokes? In 2 strokes, there are some difference. For example, in 2 strokes, the cylinder is not a cylindrical element like this. The cylinder have a couple of holes, one in each side, 2 holes, one in front of the other one, like the picture that you have on the screen right now. In the bottom of the cylinder, if you check in the picture, there are 2 holes, one practically in front of the other one. And additionally, the shape of the piston, the head of the piston in 2-stroke engines have this shape, like a castle, like this. And what is the idea? In the bottom of the cylinder, there are the holes, one hole here and other hole in the other side for exhaust, because the exhaust manifold is located here in the other side for exhaust. Yeah, one of the difference. If you check for visual inspection, the 2-stroke engines have the input of the mixture and the output of the gases in the bottom of the block, not on top. Right now, I am going to explain how the reed valves work, where are located. In this moment, this is a 2-stroke engine, 4 cylinders. Remember, the engine in outboards 2-stroke is located on top, on the power head, like the video that you have on top of the screen in this moment. Yes, the engine is located vertical. In other words, this air filter located over there is in one side of the engine. Yeah, and we are going to remove the air filter in this moment, and immediately those are exactly, this is the intake manifold, and those are the throttle bodies. The intake manifold and the throttle body is integrated. And where is located? In the crankcase. Yes, we are going to remove right now the intake manifold with the throttle body, and we are going to see the reed valves, and after that we are going to remove the bracket of the reed valves, and we are going to see the connecting rods, of course, and the pistons. Yes, we are located in the bottom of the engine. Yes, the other end of the crankshaft is in the bottom of the engine. You can see in the video that we have on the left of your computer. Exactly, that's the seal that if it's leaking, you have oil coming out in the middle section, and you have oil going out through the exhaust pipe, and the exhaust is going in through the middle of the propeller in outboards. Yes, my friend, this is the seal. This is the back seal. Of course, here we have another seal. We have another seal here, the top seal. All right, this is the crankshaft, and this is the position for 0 position. Exactly, that one. That one is aligned for the top dead center for the zero position. I'm going to explain later. Exactly, that one is aligned for zero position. In this moment you have on the top left screen the zero position, and we have the marks for advance and the marks for retard. Correct, those are the marks. Exactly. In other words, when we remove this manifold, we have the oil and air mixed. The fuel enters directly in the combustion chamber because this engine is direct fuel injection, and the injectors are located on top, on the head, and the head is in the opposite side. All right, my friends?